Recordings in progress. Good morning, y'all. This is Platoon evenings and weekends. This is the weekend. We're gonna be Dockerize and Django API. It's week 13, day 4. Django. We're getting through it. Running out of Django to teach. Not really. We got quite a bit of Django left, don't we? Yeah, 2 more weeks of it, and we won't be done with it then. So don't be upset. So we have deployed to AWS before with a full stack application, which to my understanding was just some Python, I'm guessing. Uh, but today we're going to deploy Django. One of the big changes, I guess, to what you're used to with Django is we're not just going to be running uh, the development server. So what you're used to is, what Python manage.py run server. That's the development server. That's running locally. That has a lot of debugging. That has a lot of extra stuff. When you go to the web page uh, and it blows up, Django has a really, what might seem like a bunch of hoopla and you don't like looking at it. It's actually a very useful stack trace that Django gives you. I promise you're going to work with other things that don't give you that. Um, you're gonna miss those Django you know development server messages that you see via the DOM. But we're gonna use something a little different today uh, because development servers are kind of limited in the way that they handle requests. They're going to have limitations in how fast they can churn stuff back out. They can get hammered by too many requests at one time, and they're not really capable of responding to all of them real time. We're instead going to use something called Green Unicorn. Looks like Gunicorn. Um, I, for the longest time, thought it was GNU unicorn coming from GNU, like this thing. There's a lot of stuff that use the new operating system. No, it's Green Unicorn, which is just an HTTP server for Python. We don't need to know much more about it than that. We could talk about it more if you want, but truly, really, honestly, we're just going to be invoking Green Unicorn with a command like this. This is what is going to run your Django server rather than manage.py running a development server for you. So this is the I believe button portion of this course. Just smack it and we can learn more about that later if you really want to, but it's okay. So today we're going to use Docker Compose to run 2 coordinated containers, one for Django, one for Postgres. So that we can focus more on the operational side of things, we'll start with a pre-built Django REST framework project, Wine API. Is this the first time y'all seen this Wine API? I know we use it in the course a lot. We'll be doing more with it later. Uh, it's a minimal CRUD app, and you can take a look around in the source code to see what it does. Let's flex our Django real quick. Actually, um, what's important for this? I've already forked it. I need to unfork it. Can I unfork it? Mm, you know what? I'll just have to undo my work, I guess. That's what we'll do. Let's clone it on down. Y'all see what I know I sound like I'm insane right now, but it's kind of nice to fork this for this lecture. But we'll just push to master and then I'll bring it back. Sorry, main, not master. So. Let's walk through this together. We've got 2 folders here. One seems to be the project level folder, and one seems to be the app. Mm, cool. So this is going to be kind of our base level URLs. What does this mean here? Somebody. These are slow pitch questions. Charles, what does this indicate?
Right there. I'm gonna guess that it's including the path for number of URLs that are associated with the one API. I'm gonna guess they're defined in another file or is in that folder.
Yeah, you're on the right track, right? So this is saying whatever the main URL is, if you go to slash wines slash, anything that follows that is coming from this wine API.urls. So in wine API, these URLs here, which are just base URL, and this integer um, key, those are going to have to be kind of appended on the end of it. So, HTTPS, if it were localhost, 8,000 per chance. This is saying that you need to access this app here, you're going to have to go to Wines first. So anything that you see, I like pointing at my screen like y'all can see. Anything you see here is going to be following that. So that's why, if we wanted the first wine, that's not all being handled by just this URL path here. It's kind of prepending, oops, anything from the Wines API, all those URLs are being tacked on to Wines. So this would be cool if we had multiple apps kind of going on here, which we do a little bit with the Pokemon API. If we had something for like, I don't know, beers, then we had a full different, beers app attached to this thing, this is how you would do that. So the same project, the same, website to be able to service completely different applications, um, with just a little bit of URL man or adjustment there. Does that make sense? Did I lose anybody with that? Have we seen this before, or did I just make Charles answer a question he didn't know the answer to?
Yeah, we've seen it.
Sick. Um, Beyond that, pretty simple application here. Our wine class is going to have names, a price. Notice this is being logged as an integer field, but the serializer, we'll come to that. Varietal, that's the type of wine like a red or a Chardonnay or something for y'all who don't know. I didn't know. Description created as gonna be created on some serializer, which takes the binary data class, whatever object out of Postgres, converts to JSON. This is going to be what's providing the JSON on the web page back to us. Notice price is just serializing a char field. So even though we're handing it into the database as an integer, this serializer doesn't care. It's going to treat it like a string. Doesn't matter. So we can create, we can update, looking at the views, using the Wines API view from Django REST framework. Pretty standard. If you get the base level, or so basically, if there's a primary key, we're going to go to the wine table, and we're going to grab the primary key based off of whatever is handed us into the primary key. So /1 should grab the first wine, right? Otherwise, just get them all. If we don't provide it with a primary key, if it's just wines, we should get them all. This is very conventional. Post. If you post to just the basic wines, no API, or sorry, no primary key provided, it's going to accept a this wine object, basically, result save. So it's going to take that request.data and try to push this into the database. If you put, how's the put different, Dylan? What's this put doing? Line by line. How does it get pulled up?
It is taking um the saved wine data from that variable, um, and then get object, taking the parameter of all of our wine objects on that table, right? Because dot all.
Mm-hmm.
Um,
So you may not be too familiar with how get object or 404 works, but I think we can assume that we're going to get one single wine. So how's that going to be? You said the parameter, right? So we're grabbing a wine based off the parameter.
and then a specific one based off primary key, private key.
Yeah. And why would we be wanting one single one with a put request? What's a put request do?
I was under the impression that that's just getting something, not we're not like modifying it at
We
the
are
endpoint.
modifying it.
Oh,
Yeah, no,
so that one, okay, yeah. So then that one we're actually saving it to the endpoint, right? We're like push it. No, because that would be
you're
post.
well, you're on the right track. If we're doing a put, and you can kind of deduce this a little bit, post, we don't need to have a wine selected. We're making a brand new one. Put, kind of the same thing, but we already have a wine defined. So we're taking a wine object, we're pulling one out of the database, and we're editing it basically, right? We're making a change, an update. This is the U in CRUD. A put is going to make updates to it. So what it's going to look like is we're going to look up a wine, we're going to change something about it and put it back in, right? All right. So yeah, this is going to be our create, read, update, delete. Y'all can guess what this one does. We grab a wine, buy a primary key, 4v404, dot delete. Easy peasy. Thanks, Django. And we do give a response back. You don't have to do this, but this is really nice to do. Nobody wants to interact with your API. Give it a delete request, and it's like, well, what's a thumbs up? I want to know what happened. Very nice to give a response back saying, hey, the wine that you think you deleted is this. This is the one I deleted. It's done. So fairly straightforward. No test written for this. Just a single type of app. Let's jump into it. Uh, Feel free to follow along. This should work out nicely, and it'll make y'all's assignment at the end of the day a little bit easier. Um, so you should have already been exposed to Docker Compose. This is something you've seen before. We've used Docker Compose to set up our database. We usually just say Docker Compose up, and it runs this version, whatever, services. This is our container. It's a database container. This is kind of just saying, this doesn't have to say DB. This could be foobar, but we want to know what it is we're setting up. We're going to use this image Postgres 15, setting the environment just like we always have, setting the ports, establishing volumes for where data gets saved. You need to identify the volume. Donezo. What we're going to do today, though, is we're going to add an API service to the Wine API. So we're adding another container on top of that. We're not just setting up our Postgres database with Docker Compose. We're going to set up our Postgres database and our Django and connect them together. So when we say Docker Compose up, we're going to stand up the Django we have, and we're going to stand up the Postgres all in one easy command. Sounds good to me. But before we do that, we describe the run type, blah, blah, blah. Do that, write a Docker file. Please clone down the Wine API at the root of the project, create a Docker file. I will do so. Um, yeah, I really need to fork. Let me pause real quick because I don't want to jack up the curriculum just for this. Recordings resumed. Y'all, all I did was delete my fork and created another fork so that I don't need to push this to a whole class. So you see Jordan West, DRF Wine APA. That's the one I'll be cloning down. So let me do that now. Not use this one here. Cool. It didn't change, but it actually did change. All right. Let's create this Docker file. Talk about it just a little bit. New file. Docker file. You usually see Alpine here. What is Buster? It's a development kind of image. It's Alpine with a few more things built up into it. It explains it at some point here. Starting from Buster just makes our lives easier. You can look up the Buster image if you want. It's got a lot more development tools kind of built into it, so we don't have to quite install extra stuff on top of the image. Basically, it's got a lot of Python built into it. It'll help us out a little bit. We're not going to have to install Psycop G2, for instance. It just comes with some stuff. Normal. We've seen all this before. This is the new thing that we talked about a little bit at the beginning of class. We're going to be using Green Unicorn to start the server, not Django. We don't want Django to do it. It's going to set up 3 different workers based off of this. We're telling it where the API, basically where the application's running from. Workers are like, they're not servers. They're just processes that are going to be accepting requests. They're like 3 different kind of, not really ingresses, kind of like ingresses. One single ingress, different workers spinning off, accepting 3 different jobs. So if 3 different people hit it all at exactly the same time, feasibly, there's 3 different processes running it. I don't think it breaks it down quite that simply to understand, but more workers is more ability to respond to requests. 3 is not a lot, by the way. You can see things like in the tens of thousands. We're not going to be doing that. Yeah. So this does cover it. This is why we don't use the usual Alpine image because of Psycop2G, Psycop PG2, I don't know how you're supposed to say this, but it's that. Buster makes our lives easier. So next we'll install the DRF application dependencies and copy over everything. When we run it, we'll have Green Unicorn handle the request. Next, we'll add a container, just as we described, to the Docker Compose file. So adding a new container here, this differs from what you've seen in the Pokédex, Pokemon app. What are the containers? How many containers are shown here? Michael, Meyer.
I believe is it 2 because you got you got 2 services?
Yeah, absolutely right. Yeah, sir. Think when you see services, think containers, right? So this is our normal database container, and here's our API container. Easy peasy, right? Let's man, I am just not speedy in the mornings. So we could copy this whole thing effectively. We probably should because this changes a few things, but let's look at what we're updating here from what we've got.
I have a quick question.
What's up?
The README says to put the Docker file at the root.
Mm-hmm.
Is it in the API or in the project? Where is it supposed to go?
Yeah, so generally when you say the root, that means the highest possible level within the project, within where you're working. Because this Docker file is going to need to access. Did I jack y'all up? I put it in the wrong spot. Is that why you were asking, or do you still, does that answer your question?
I just wasn't sure what if it meant like the root of the project. So the lines file. I just didn't know.
Yeah, it does. You will constantly see me struggle with this stupid tree over here. I like to do things from the terminal. I lose people, so we're going to kind of do this. It needs to be at the top level because this Docker Compose, and Docker file are going to need to reference both of these containers. So they need to be above, it needs to be above it so it can have access to both of them. That's a way to think about it. Some changes between what we're starting with and where we're going. You will see we're adding the API container. That's easy. Done. Fix my YAML. The other change we see here, notice we were specifying the port for git blame is so annoying. We used to specify the port for the Postgres container. We were doing this because the Postgres container was running in Docker, right? We'd push up that image, we'd run that image in Docker, but we were still running Django locally. So we needed to port forward localhost to point at that container. Am I losing y'all? We're not going to do that now because they're both running in the same pod. They're still running in the same Docker image. So instead of telling it, hey, you need to go to localhost and this port, it's just going to look at localhost for itself. So we don't need to specify ports anymore. Because again, these are going to be running on the same host. They're staying at the same level. There's no more localhost us talking to container. They're both in the container. So they don't need to specify ports. We don't need to port forward. This is fine. And just to be extra super safe, let's just paste. Nothing changed, but don't want to fight with this for you guys. The API service is a little bit different, the database, because the API service is being created from a local Docker file, build dot. In the Docker file, we told the application to run a port 8000 in the container. We'll map that to the same port on the host machine, but we can change it if we wanted to. The depends on field tells Docker Compose that it should run the database service first. Basically, that right there is saying, hey, please start the database before you start the API. That makes sense, right? You can't start Django without a database to hook up to it. You also need to update the database connections in Django's project settings.py. Super useful file here. So within the project, we've got settings.py. We just scroll on down or search. Oh my goodness. Is this, if I were the creator of Django, I'd alphabetize my settings.py. Okay, so because the Django application and Postgres container are now running on the same network, they're going to communicate directly. This host here is not going to be localhost. We're just going to point it at the container. So we're going to change that to database. Everything else is as I expect. Oh, and this is the port on the host machine. Django container and Postgres are on the same network now. We're just going to set it to 5432. This should be its default. We don't need to overwrite that. Whoopsies. All right. At this point, we could go ahead and run Docker Compose up. However, we will also need to run migrations. For that reason, we're going to add another layer on top of the Docker Compose to coordinate that. I like scripts. This is a script. Very cool. This script is basically just going to run these lines one by one as you normally would. But why type 4 different things? Well, you wouldn't need to sleep probably. Why type 3 things into our container once it's deployed to make it more complicated? Let's do it all here. So at the highest level possible, what do we call this? Run compose? Is that what it doesn't really matter what we call it. Within run compose, we're going to do this Docker compose up-d build. Familiar with that. Make sure Postgres container is ready, then run migrations. This is assuming that's enough time to get this going. Sleep 5 seconds. Then we're going to run Docker exec, which is going to exec into the container. This is roughly the name we expect it to be. It might change when we get it up onto EC2 instance. We'll take a look at it at that point. But we're assuming this is the name it's going to build out for our application. It looks at our folder, looks at the container, and then indexes it, right? So drf wine API That's, the name of the folder. This is the API container as, designated by this in our services, in our Docker Compose. And then -1, there's just one of them. And then we're going to run, looks crazy. It's not. This is just Python manage.py make migrations. And then migrate. So if everything works out right, when I run this file, it should Docker Compose to stand up our database, our API, and then we're going to perform migrations. So we don't have to get in there and do that. Make sure you chmod change mode of operation. There's a few different ways to do this. I'm not going to teach y'all 8-bit binary because I don't like it, even though it's a little bit more specific. Chmod, feel like we talked about this a little bit. Oh, that's not how you do that. We'll just man it. Change file modes or access control lists. If you want to make something executable, most files you make by default are not going to be executable. See this run compose. User has read write permissions. Group has read permissions. Everyone has read permissions. We want this. We want that X. Mod plus X. This is the easiest way I know to do it. If you want to be specific, you can say the user is going to be able to execute it. The group could execute it. All could execute it. Plus X means just add execute to all. And we can dig into this a little bit deeper if you would like. Basically, this is saying change mode of operation, allow anyone who accesses this the ability to run it, execute it. If we did that right, check it out. Added an X to the user, the group, and everyone. And it's red now because Bash picks up on that. Z-Shell picks up on that and says, hey, this looks executable. I think if you wanted the binary way to do that, it would be chmod 400 run compose. But again, I'm not super good at remembering my 8-bit binary or 8-number binary. The run compose script will run Docker Compose up. Wait a few seconds to run migrations. For the sake of symmetry, you could also create this stop compose shell. Notice this is a script that runs one single line. Not a big fan of that, but I am a fan of symmetry. So let's go ahead and be in here. Do this way, just so y'all can see stop compose.sh. That should open one up right here. Docker compose down. Chmod plus X. Stop. There we go. And that's where the lecture ends. However, in your assignment, you're going to deploy it to AWS. So let's deploy this to AWS in the next video.